Hi. So for this video, we will be discussing integrals that lead to logarithms. So we have a very simple formula. So we have the integral of du over u is equal to ln of u plus c. Okay. So in this integrand, so we can see that it's in fractional form, and integrals that lead to logarithm are those fractional integrands for which the numerator is the complete differential of the denominator. Okay, so if we have those integrals or integrands, then our integral is equal to ln of u plus c. So this is the special case for general power formula where n is equal to -1. Okay, so if you recall the formula for the general power formula, then it says there that n, or the exponent of u, is not equal to -1. Okay, so if n is equal to -1, then we now use this formula. Okay, so to apply that in some examples, so example number 1, so integral of v dv all over 6v squared minus 1. Okay, so let's apply the formula. Integral of du over u, so our u here is the denominator, so u is equal to 6v squared minus 1. Okay, for us to apply this formula, then the numerator should be the complete differential of the denominator. Okay, so our denominator is u, its complete differential du is, so differentiating 6v squared, so that will become 6 times 2, so that is 12v dv. Okay, so as you can see, the complete differential of the denominator is 12v squared dv, and in the numerator we only have v dv, so therefore there is a missing factor of 12. Okay, so similarly with what we did in the general power formula, if it's only constant that is missing in the integrand, then all we need to do is add that constant coefficient that is missing, and then write its reciprocal outside the integral sign. So this will now become integral of v dv over 6v squared minus 1. Okay, so again, the numerator, for us to apply the formula, then we need the coefficient of 12. Okay, so the numerator should be 12v dv. Okay, so therefore we add 12, and in multiplying the numerator by 12, we also have to multiply the denominator with the same. Okay, so but since this is constant, so therefore we can write it outside the integral sign, so 1 over 12. Okay, so now our numerator is the complete differential of the denominator, so then we can now apply the formula. Okay, so this will become therefore 1 over 12. So the integral of 12v dv over 6v squared minus 1 is ln of 6v squared minus 1. Okay, plus c. Okay, so it's that simple. So all we need to do is complete the differential, okay, in the numerator part. So the numerator should be the complete differential of the denominator. Okay, so another example, so we have integral of y minus 3 dy all over y squared minus 6y plus 1. Okay, So applying the formula, our u here would be y squared minus 6y plus 1. So our complete differential should be 2y minus 6 dy. Okay, so as you can see, this should be our numerator. Okay, so as you can see, we have a missing factor of 2 in the numerator, because if we factor out 2 here, so this will become 2 times y minus 3 dy. Okay, so we have a missing factor of 2, so all we need to do is complete the numerator. So rewriting, so you have y minus 3 dy over y squared minus 6y plus 1. Okay, so the numerator has a missing coefficient of 2 to complete the differential. So write in the numerator 2. Then in writing 2 in the numerator, we must write 1/2 outside the integral sign to balance that out. Okay, so therefore, since the numerator is already the complete differential of the denominator, then we can now apply again this formula. So this will become 1/2 ln of y squared minus 6y plus 1 and then plus c. Okay, so another, so you have integral of cosecant theta cotangent theta d theta all over 1 plus cosecant theta. So obviously our u is the denominator, which is 1 plus cosecant theta, and our du should be the differential of u. So differential of 1 is 0 plus the differential of cosecant theta is negative cosecant theta cotangent theta d theta. Okay, so therefore our du should be negative cosecant theta cotangent theta d theta. Okay, so as we can see, our numerator is positive. Then all we need to do is multiply it by negative 1. So this will become, rewriting cosecant theta cotangent theta over 1 plus cosecant theta. Okay, so the numerator should be negative cosecant theta cotangent theta d theta. So therefore we must write here negative, and then outside the integral sign we also multiply it by negative 1. So therefore, since the numerator is the complete differential of the denominator, then all we need to do is apply the formula. So write the negative, so negative ln of 1 plus cosecant of theta plus c. Okay, so last one, so we have integral of dx over square root of x, then 1 plus square root of x. Okay, so this actually is, we can rewrite this as integral of dx over square root of x over 1 plus square root of x, where our u is equal to 1 plus square root of x, and our du is equal to, so differential of this is 0, differential of square root of x, so you should memorize that, that is 1 over 2 square root of x, or dx over 2 square root of x. Okay, so to apply the formula, so we have a missing coefficient of 1/2, so 1 over 2. So we should multiply the numerator by 1/2, and then outside the integral sign, multiply the reciprocal of 1/2. So which is equal to 2. So dx over square root of x plus 1 plus square root of x. So again, the numerator has a missing coefficient of 1/2. So multiply here 1/2. Then outside, so multiply it by 2. Okay? So since 2 is the reciprocal of 1/2. So therefore, our answer now would be 2. Then integral of this is ln of u, which is 1 plus square root of x and plus c. Okay, so that's how simple this integral is. Okay, so all we need to do is make sure that the numerator is the complete differential of the denominator so that we can apply this formula. Okay, so that's all